We are doing section 6.1 slope fields. The first thing we're going to be doing is verifying solutions of differential equations. Now they give us a differential equation y double prime minus y equals 0, and we're given the function y equals sine of x. So the first thing we need to do is find y double prime. Y prime is cosine, and y double prime is negative sine. And then we plug everything in where it needs to be. So negative sine of x minus sine of x. We're trying to check if that's equal to 0. This is negative 2 sine x, which is not equal to 0, so this one is no. That's not a solution. B, y prime equals negative 4e to the negative x, and y double prime is 4e to the negative x. So y double prime, 4e to the negative x minus 4e to the negative x. Is that equal to 0? Yes, it is, because they cancel. And c, y equals ce to the x, where c is just a constant. Y prime is ce to the x, and y double prime is also ce to the x. So y double prime minus y is equal to 0, yes. Okay, now we're going to find a particular solution to a specific c. We have a differential equation x y prime minus 3y equals 0. Verify that y equals c x to the third is a solution, and find the particular solution determined by the initial condition y equals 2 when x is negative 3. So what we're going to do is we need to find y prime if we're going to determine if it's a solution or not. So y prime is 3c x squared. So x times y prime, 3cx squared, minus 3y, y is cx cubed, checking if that's equal to 0. This is 3cx cubed minus 3cx cubed is equal to 0. Yes. So now we're not trying to find the particular solution. That means we need to find what c is. So we're going to plug in 2 for y and negative 3 for x. And c is negative 2/27. So our particular solution is y equals negative 2/27 x to the third. So that was the first part. The second part is doing the slope fields themselves. Now what a slope field is a graph of little dashes that tell you what the slope is at each individual point. So if we know what the slope is, that means that we have the derivative. And this y prime equals x minus y is going to represent the derivative at any point. So we're trying to identify it for the points negative 1, 1, 0, 1, and 1, 1. That's just putting in the x values and the y values, and y prime is the slope. So at negative 1, 1, our y prime is negative 1 minus 1, or negative 2. At 0, 1, our y prime is 0 minus 1, or negative 1. And at 1, 1, y prime is 0. So if I say this is 1, this is 2, negative 1, negative 2, 1, 2, negative 1, negative 2. We'll be able to see our dashes a little bit better. Now you don't have to make the dash too big, but you do need to be pretty careful as to differentiating between negative 2 and negative 1. So at negative 1, 1, our slope is negative 2. So like that. At 0, 1, our slope is negative 1. So notice how the difference between my two dashes, the one at negative 1, 1 is a little bit sharper than the one at 0, 1. And at 1, 1, our slope is 0, which is a horizontal line. Okay, so it's a very small slope field. Most slope fields have several points. So if we go down below, we have 3 slope fields where I approximated the slope at all of these points. And we need to figure out which graph goes with which. So what you're going to do is identify several points, figure out what the slope would be, and then pick between graph 1, 2, or 3. So if I look between 1, 2, and 3, if I want to see some points that are different, it looks like I could pick 0, 0 every time is going to be 0, so that's probably not the best one to pick. Maybe 1, 0. I'll find the slope. And -1, 0, -1 would be a good one. One more. Maybe we could pick 0, 1 as well. Hopefully this helps. If we have slopes that are pretty similar at those points, we'll have to pick some more. So for A, y prime would be 1. Here, y prime would be -1, and here y prime would be 1 again. So we're trying to find which one of these three graphs has a slope of 1 at 1, 0, and 0, 1. It looks like the only one that happens at is graph number 2. So A is graph 2. Pick the same points for B. Y prime is 1, and then 0 for both of the other ones. Only one that happens on is graph 1. And let's just double check, pick the same points for C and make sure that they make sense. If they don't, we'll have to do some rethinking. And it looks like at 1, 0, our slope is 0. At 0, -1, our slope is -1. And at 0, 1, our slope is 1. So yes, graph 3 for sure on this one. Okay, now the last thing we're going to do is make a slope field. And I think the best thing to do is pick about 15 points or so. And to do that, I like to make a big table. Okay, that's actually 15 points right there. So I think it's, I'm going to go by ones again like that. Just so we can tell the slopes apart. It'll be easier to tell. I'm going to pick, starting at -2, I'm going to pick -2, -1, -2, 0, and -2, 1. Then I'm going to pick -1, -1, -1, 0, and -1, 1. Same pattern the whole way. This is 1, -1, 1, 0, 1, 1. And same thing with the 2's. 2, -1, 2, 0, 2, 1. That'll give us a good vision right around the origin. So at -2, 1, that's -2 times 2 minus 1, it's -5. -2, 0 is -4. And -2, 1 is -3. -1, -1 is -3. -1, 0 is -2. -1, 1 is -1. 0, -1 is -1. 0, 0 is 0 and 1. -1, -1 is 2 minus 1, that's 1. 1, 0 is 2. 1, 1 is 3. 2, -1 is 3. 2, 0 is 4. 2, 1 is 5. Okay, so I'm going to go through and do the best I can to sketch at each one of those points. And it's going to be really hard to tell the difference between these slopes because they are so similar. But do your best. Okay, so that's the best that we could do to draw the slopes at each one of those points. Now we're going to just sketch a graph in there so I can give you an example of what this would look like. So it looks like there's going to be a horizontal around 0, and then the slope's going to increase. Looks like it's going to be a parabola. And that's kind of the point of what you're going to be doing. So 15 points is a good number of points. And your homework's on the bottom, and that was section 6.1.